What's up, guys? Day 4 of the 100 Days of LeetCode, and we are going to be doing a slight modification on a classic. A classic. This is going to be the nth Tribonacci number. Now, if you guys are familiar with the two different ways, the naive way and the good way of solving the Fibonacci solution, this Fibonacci sequence, um, this this problem needs to follow the same logic, or else you're going to face the exact same problem that you can face implementing the naive solution in the Fibonacci. So we're going to start actually by looking at sort of the Fibonacci problem and the two different ways to solve it. The one way, which is very slow, and the other way, which is very fast and efficient and elegant and uses dynamic programming. So let's look at it. So I prepared this Visual Studio Code file in Python, um, and I've imported the timeit module, and we're going to benchmark the code a little bit. So this is the naive Fibonacci solution. So basically, if n is 0, we return 0. If n is 1, we return 1. Else, we're going to return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Now, if you guys don't know what the Fibonacci sequence is, it's a sequence of numbers starting at, if you want to just look down here at the terminal, I'll type it out, starting at 0 and 1, and each new entry in the sequence is the sum of the two previous numbers. So we have 1 because that's 0 plus 1. Now we have 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, and that goes on forever. So Fibonacci of 0 would be 0, because this is the 0th index. Fibonacci of 1 would be 1, Fibonacci of 2 would also be 1, and then Fibonacci of 3 would be 3, 4 would be 3. Where are we at now? We're at 5, I believe. Yeah, it would be 5, and so on. Now, if we try to calculate it like this, what's going to happen is on the call stack, we're going to be calculating Fibonacci of, say, 10 tons of times if we have a much larger number, because to get each Fibonacci number, we need to calculate all the numbers beneath it to have that function be returned up the stack to the initial calling function. So what that means is we're basically going to create an incredibly slow program, and it doesn't need to be that way because we have a much better way to solve it. And we can use what's called memoization, and it's a dynamic programming practice. It's pretty easy, and that will make things just a lot quicker and easier. And you'll see when we run this code and it's benchmarked, and you'll see the difference. Anyway, the way we do that is we declare the function, we create an array, and right now I've just initialized it to have 100 spots in it. They're each initialized to -1. You can do that larger or smaller depending on your needs. And inside that function, the way I've implemented it is I've just declared another function, Fibonacci function, and now this time we're going to check that array to see if we've already calculated that particular Fibonacci number. And only if we haven't are we going to do these recursive calls. So what this does is this saves us from branching out basically into recursive Armageddon. And at the end of that, we're going to be returning fib of n, which basically enters this whole sort of recursive spiral. Now, I've used the timeit module to benchmark this code and see what happens. Okay, so first of all, what it's outputting is outputting the number for Fibonacci of 25, and it's also outputting, this is a time in seconds, so really what this is saying is that it's, what would that be, almost 20 milliseconds. So that's how long it takes to calculate it for 2025 using the naive solution. Now, this number, which is expressed in scientific notation, is a very, very small number. So I'm going to pull up on my other screen here a scientific calculator, and I'm just going to let you know how fast that is. So this number is that. So you can see that it's several order of magnitudes smaller than the number we get for the naive solution. And now if I even up this to say 50 and I try to run this code again, it would take forever. It probably wouldn't even finish on my computer. So that we have to approach the Tribonacci problem in the exact same way. All right, so let's kill that process. Okay, cool. So we're going to do a memo array. We're going to initialize them all to -1, and we're going to do 38 spots in that array, and we're going to define another function. We can just call it trib, which takes an int, and we can just, for the sake of completeness, we can just let it know that it's returning an int. We can say if n equals 0, we're returning 0. If n equals 1, we return 1. Now, we also want to just use 2 as a base case, and we can just say if n equals 2, we're also going to return 1. Now, as we're looking over here again, if we're modeling it based off that solution, we can say if memo n not equal -1, and we can return memo n. Now, looking back over there again, we can say memo n in the else statement. Memo n will simply be equal to trib n minus 1 plus trib n minus 2 plus trib n minus 3. And we're going to return memo n. And from this whole Tribonacci function up here, we're going to return trib of n. And there you go. Problem solved. All right, thanks guys. If you guys want to hop on the 100 Days of LeetCode train, I appreciate you liking and subscribing. We got another, 96 days, so come on, let's do it. Take care.